James Watt was a Scottish inventor born in Greenock in 1736. It was whilst Watt was working as a mechanical engineer and instrument maker at the University of Glasgow that he was asked to repair a working model of Newcomen's steam engine. He came to realise that Newcomen's engine design was less than efficient. With every stroke, energy was being wasted as a condensing cylinder was being repeatedly heated and then cooled. Watt's solution to this problem was to build a steam engine that incorporated a separate condenser. Watt sporadically developed his engine between 1763 and 1775, and as we can already see, there's a little bit more to this than that of Newcomen's engine. So let's take a moment to examine its main features. It's the combined furnace and boiler that produces the steam, which is then transferred through the steam pipe to a series of inlet and exhaust valves, which in turn are connected to the piston cylinder. The piston is connected to the beam, which operates the rotary arm, one end of which is a static cog known as the planet, and that appears to rotate about another cog known as the sun, and it's this sun and planet gears which operate the flywheel. We also have a cold water tank and a hot water tank. In this cross section we can see that Watt's engine is double acting. That's to say that steam enters the cylinder at each end alternately, forcing the piston up or down. This process is controlled by the engine's valve gear, shown here in this cutaway. Active steam alternately enters the valve systems at these points here, whilst the exhaust steam exits the system through these pipes, all of which is controlled by a plug tree or rod, which is again linked to the beam. Here we can see the exhaust steam pipe leading into the cold water tank, in which are housed two cylinders. This is a separate condenser, and the other is a pump which extracts the condensate into the separate hot water tank, which then recirculates back to the boiler.